8.4 laws of logarithms. So remember, laws of logarithms are going to be very similar to the exponent laws. Okay, so the product law for an exponent, so if we have some base a to the x and it's multiplied by the same base, okay, so these are same bases. That's required for product and quotient law, okay? What ends up happening is we add the exponents. Okay, well, for laws of logarithms, log base a, again, same thing. We have to have the same bases, just like in the exponents. Okay, if we have x times y, we can break this up into the log base ax plus the log base ay. Okay, quotient law, a to the x divided by a to the y, what we're doing is subtracting the exponents. Likewise, the same thing's going to happen when we do laws of logarithms. If we have x divided by y, so log base a x divided by y, it's now going to break down into subtraction. Log base ax minus log base ay. Okay, and then power law. A to the x to the y, we end up multiplying these. So I'll show you how this works. Log base ax, we can take this r, and instead we can multiply r times log base ax. Okay, so let's take a look at how this actually looks in questions. Okay, example 1, write each expression as a sum or difference of logarithms. So log 73 times 21. As a reminder, this is base 10. We don't have to write base 10 though. We can just write log 73 plus log 21. Okay. Likewise, if we have log 84 divided by 13, this is the quotient law. So we can just write log 84 divided by log, oh, sorry, that's going to be subtraction. Subtract log 13. And these two expressions are equivalent. Okay, or we can go backwards. So if we have log 3 plus log 8, we want to write each expression as a logarithm of a product or quotient. So specifically this time, we want product, which is multiplication, or quotient, which is division. So log 3 plus log 8 can be written as log 3 over 8, 3 times 8. My mistake. Because they're added, that's the multiplication. Okay, and log 9 minus log 4, we have log of 9 over 4. Okay, example 3. Express each of the following in the form r log base ax. So we have log, obviously base 10, 5 to the 8. We can bring the 8 in front. 8 log 5. And log 3 to the 7, we could bring that exponent 7 down, so it's 7 times log 3. Right. Example 4, simplify each logarithmic expression. So this time you have to, like, simplify means make smaller. Okay, so you can put make smaller. So this time you have to look back to the laws of logarithms, and you have to choose which one we're going to use. Okay, so log base 3, 6 plus log base 3, 4.5. So both of these have the same base, so that's beautiful. We can work with it. Okay, since we have the addition, we know that we have to multiply 6 times 4.5. Okay, but if you think about it, we want this simplified, so let's keep going. Log base 3 of 27. Okay, well, you got to think. So this is what we've done up until today, but simplify means keep going. So as far as you can. So let's think about this. How can we rewrite 27 as a base of 3? 3 cubed. So now we're using yesterday's properties. We get this simplifies to 3. So this full expression simplifies to 3. All right, log base 248 minus log base 23. So this is good because we have the same base. So we're going to have log base 2. And since this is subtraction, we're going to do 48 divided by 3. Okay, so that's what we've done up until today. Now, from the last lesson, 48 divided by 3 is 16. So what we can do is we can change the 16 to 2 to the 4. And then we know that this cancels to 1, and we get this equals 4. Let's write that all the way down. Okay, log base 5, cube root of 25. I think we've seen this one before. So let's rewrite this as 25 to the 1/3. Okay, we can, I'm just going to use the laws that we have here. We can bring this 1/3 down. So we're going to get 1/3 log base 5 of 25. And those are multiplied. Okay, those are the laws that we use today. Now, combining them with the laws that we used in the previous lesson, we can change this 25 into a base of 5. So it's going to be 5 squared. So log base 5 cancels out. We get 1/3 times 2, and we get 2/3. Example 5, use the properties of logarithms to express log base A of this radical here in terms of log base AX, log base AY, log base AW. Okay, please note there are no exponents. No exponents. Okay, so what I'm going to do is I'm going to first express this as log base A, and then I'm going to put this into a bracket. X cubed y squared over w. And instead of having a square root, I'm going to raise this to the 1/2. Okay, then in the next step, I'm going to bring that 1/2 in front. 1/2 log base A, and all I'm doing here is rewriting that fraction. Okay, so I'm going to bring down the 1/2 log base A, and now this fraction here, I am going to split up. So we can rewrite this as x cubed. You know what? I'm going to do a big bracket because I'm going to rewrite x cubed, y squared, and w completely separately. So because x cubed and y squared are multiplied, we can add those. Log base A, y squared. You can bracket, you can leave it, doesn't matter. Okay, and because the w is divided, we would then put minus log base A, w, and big bracket. Okay, and we put the big bracket because we essentially brought down that 1/2, and we expanded this log base A of this fraction. Okay, and then what we want to do is we want to distribute this 1/2 into the bracket. So we get 1/2 log base A of x cubed plus 1/2 log base A of y squared minus, 1/2 log base AW. Okay, so all we did is take that 1/2 and distribute it into the bracket. Okay, so in the original, we can see that none of these have exponents. So what we're going to do is we're going to take this exponent 3 and we're going to bring it down and multiply it by the 1/2. So we get 3/2 log base AX. Okay, we're going to take this exponent 2 multiplied by 1/2. So that'd be 2/2, which is just 1. So we get log base AY minus 1/2 log base AW. And it's at this point where we're done because we have expressed everything with a log base AX, which is up here, log base AY, which is here, and log base AW. Okay, example 6, evaluate. We have log base 2,4 plus log base 5, 125. So it's at this point where we want to apply any of the log laws that we know now. Okay, so I'm going to apply log base 2 to, let's go 2 squared, plus log base 5, 5 squared. Log base 2 of 2 cancels out, we're left with 2. Log base 5, 5 cancels out, we're left with 2, and 2 plus 2 is 4. Okay, so log base 5, 75, minus log base 5, 3. So right here, what I'm looking at is like, I can't rewrite 75 with a base of 5. So instead, what I'm going to do is I'm going to focus more on this negative sign. And I'm going to rewrite this as log base 5. And because these are subtracted, I'm going to write 75/3. Okay, so I now get log base 5 of 25, which I can rewrite as a base of 5. It's 5 squared. Okay, just like the last question, log base 5, 5 cancels out. And my answer is 2. I'm actually going to go back to A. So with A, if you didn't see it, or if we don't have nice numbers the way we did over here, we could have actually rewrote the log base 2 because oh, and then this is 5. So no, we couldn't have rewritten it. We're good. Okay, we would be unable to write this as the product of 2 numbers, like the log base, because the bases are different. All right, this should be C. Okay, we have 2 log 5 plus log 4. So both of these have a base of 10, and we're not going to be able to write 5 as a base of 10 or 4 as a base of 10 without it being approximate. And we don't want approximate numbers. Okay, not for logarithms. So what I'm going to do is I'm going to bring this 2 up, and this is going to be rewritten as log 5 squared. Okay, plus log 4. And now because there's no numbers in front, and this is added with the same basis, of course, 10, we can rewrite this as a product of log base 10, 5 squared times 4. And that's it. So 5 squared is 25, times 4 is 100. Okay, if you want to write the 10s in here, you can. If you don't, that's okay too. And at this point, we're thinking to ourselves, 10 to the exponent what equals 100? So 10 squared equals 100. You can cancel that out. The answer there is 2. Okay, correction. 5 cubed, let's write that in dark green, is 125. Because 5 cubed and 125 should be a direct substitution, which makes this 3, which makes this 5. And if they're exact numbers like this, you can always check these in your calculator. So what we're going to be learning today is, if we have log base 2,4, we can convert this to use in our calculator to like a base 10 by writing this as log 4 over log 2. So in our calculators, if we have log 4 divided by log 2, and then plus, and then this, so this would be log base 5, 125. We could do log 125 over log of 5. And for these, we should get 2 plus 3, and we should get 5. So you can always check your solutions as well. And we're going to get more into this today. Okay, we're going to do this again. Example 7. Use the law of logarithms to express each of the following in terms of log base bx, log base by, and log base bz. So remember, we don't want any exponents, okay? So no exponents. All right, so we have log base b x squared y cubed z to the 4, okay? So unlike 2 examples ago, this one doesn't have an exponent on it, so we can just go straight into the addition subtraction, okay? Like the product quotient laws. So log base b, and we're going to have x squared. And since x squared and y cubed are multiplied, we're going to add log base b y cubed. And then because we're dividing z to the 4, we're going to subtract log base b z4. Okay, and then there's just one more step here. We're going to bring the 2 in front, the 3 in front, and the 4 in front. And then we're done. 2 log base bx plus 3 log base by minus 4 log base bz. Okay, so we build with b, log base b, and then I'm just actually going to rewrite this as first, log base b, we have x to the 7 over y squared z to the exponent 5, and I'm going to raise this to the 1/2. And we're able to take that 1/2 and put it in front of the log, and only at that point, when we rewrite this with the 1/2 in front, are we able to actually break this down into the quotient product, or like the plus minus. Okay, so we are breaking down log base b to this fraction. So the 1/2 is going to stay out front, and we're going to have log base b x to the 7. So x to the 7 is divided by y squared. So because it's divided, we're going to go minus log base b y squared. It's also divided by z to the 5. So again, minus log base b z to the 5. Okay, I'm going to do this one backwards of what we did before. I am going to bring down the 7 first, bring back down the 2 first, and bring down the 5 first. It doesn't matter which order you do these in, and that's why I'm showing you this order. So 7 log base bx minus 2 log base by minus 5 log base bz. Okay, last step, I'm going to distribute this 1/2 into the brackets. Okay, the number that it distributes onto is that coefficient. So we're left with 7 over 2 log base bx minus, so this is going to be minus 2 over 2, which is just 1. So I'm not going to write it. I'm just going to write log base by, and then minus 5 over 2 log base bz. Okay, C, log base 8a 2 to the root 2 plus log base 8 cube root of 16. Okay, I'm going to rewrite this so that I have exponents that are rationals rather than the radical here. So this is going to be rewritten as log base 8, 2 times 2 to the 1/2. And this side is going to be written as log base 8, 16 to the 1/3. This is actually not bad because we have both of these are base of 8. Now I'm just going to, I'm looking at this. We have 2 to the 1 times 2 to the 1/2. I'm just going to collect those. So when we usually apply exponent laws, we're usually applying them with the same base as a variable, we can do the same thing if the same base is a number. So essentially this is going to be 1 plus a half. So I'm going to change this to 2 to the 3 halves. Okay? And you know what? Why not? Let me just change 16 to the 2, like a base of 2. So 2, 4, 8, 16. 16 is going to change to 2 to the exponent 4. Okay, 16 is 2 to the 4. And I'm going to raise that to the 1/3. Okay, so now I'm just going to rewrite this. Okay, so the first term I just rewrote. The second term, I'm going to collect these. I'm going to do like the 4 times 1/3, so 4 over 3. So because these two terms have a log base 8, we can rewrite this as log base 8, and we can collect the bases. So because they're added in between, we can write this as 2 to the 3 halves times 2 to the 4 thirds. And without doing much math and just going straight onto my calculator, I'm going to do 3 halves plus 4 over 3, and I'm going to get 17 over 6. Okay, so I get log base 8 to the 2 to the 17 over 6. Okay, and because we have to write this with no exponents, we're going to bring this to the front, and it's going to be 17 over 6 log base 8, 2. Okay, example 8. Solve for x. So we have log x equals log 50 plus log 2. Okay, so first of all, we have too many logs in here. I'm going to collect these so that we have log x equals, this is going to be log 50 times 2, which is going to be log x equals log of 100. Okay, we know as soon as you see 100, 1,000, 10,000, it should trigger your memory to be like, oh, well, we know log base 10 of 100 is 2, right? Okay, so we have log base 10 of 10 squared, obviously, which cancels to 2. So we have log x equals 2. So you got to think back to the original. This is a base of 10. 10 to what exponent equals x? Okay, can't really solve that. So we want to rewrite this in exponential form. This is going to be 10 to the 2 equals x. Okay, 10 to the 2 equals x. And it is going to be 100. And because this question started with an equal sign, we are actually solving. Okay, and that's why there's an equal sign in the last line there. So B, we have log x plus log x minus 1 equals log 2. Okay, so let's look at this. These two can be multiplied. So log x times x minus 1 equals log 2. And then because we have one log on each side, we can actually drop the logs right now. We could have done that in the previous question, but the previous question, the numbers were easy to like see and look for. This time they're not so easy. So essentially, because essentially what happens here is we can raise both like to the exponent 10. So 10 log base 10, that would cancel. And then 10 log base 10, that would cancel. That's essentially what we're doing. And we're going to be left with x minus 1 equals 2. Okay, we're going to distribute the x. So we have x squared minus x. Bring this 2 over. Minus 2 equals 0. So at this point we have a quadratic. So we're thinking what two numbers multiply to negative 2 add to negative 1? I get negative 2 and 1. So after factoring this to x minus 2, x plus 1, we get two solutions, x equals 2 and x equals negative 1. Okay, I want to talk about these articles, okay? So when we take a look at this bracket beside the log, okay, this is called an article. Okay, so any article in a logarithm must, like, there's going to be a restriction that that article has to be greater than 0. Okay, just as a reminder, log, whatever base it is, can't be negative. So cannot, let's go, has to be positive number. Cannot be a negative number. Okay, so there's going to be 2 restrictions here. Log base x is going to be x is greater than 0. And log x minus 1, we're going to have x minus 1 has to be greater than 0. So x is greater than, 1. So coming down here, this second answer is going to be inadmissible because it's not in the domain. Okay, and then over here, just like throwing this out there, if we actually took a look in the original, we do have a log x. We could also put like a comma and put like x is greater than 0 as the domain.